Hi, welcome to Teardown Tuesday. Yes, we're going to take a look at this brand spanking new, hot off the press, practically not available yet, Siglent SDS 1000X series oscilloscope. You know what we say here on the EEVblog, don't turn it on. Again, take it apart. As with most little modern compact scopes like this, looks like we've got some screws, 4 screws down the bottom here, and, well, where are the matching ones on the top? Well, yeah, under the handle there. And look, this is interesting, they've got no threaded nuts, no nuts on the B&Cs. That's nice and convenient to take it apart. Beauty. Once again, thanks to Charles at Trio Test and Measurement, who's has kind of reluctantly agreed to let me tear down the only unit in the country. So, yeah, let's hope I don't break it. Is it just me, or do those little gold QC pass stickers not instill, you know, QA and QC pass stickers not instill a lot of confidence? I'm just used to seeing those on, the $2 eBay crap items you get. I don't know, it's just gives me a bit of the heebie-jeebies. First of all, though, what I'm going to try and do is get this pesky warranty void if removed sticker, nice little Siglent hologram thing there to know that it's genuine, and try and get this off so that Charles will feel a bit better, or maybe if he doesn't watch the video he won't know that we took it apart. And, well, hello threaded machine inserts, but I think they might be going into plastic, but they've got some thread locker on there too, so it'd be interesting to see once we take it off if there's actually a metal threaded insert in there. That'd be impressive. I am in like Flynn. Errol, that is. Alright, so we're in, and heavy shielding as we've come to expect on all of these type of scopes. Look, we've got another B&C down there, unpopulated. I wonder what that is. A second ARB channel or something, maybe? Anyway, looks like we've got some sort of programming header there, and there, and there, and an unpopulated header down in there. So anyway, we can see the board down there. Looks like it's looks like it should be one big board under here, so we should be able to see everything on it. Hopefully I don't have to like take the whole thing out, flip it over the other side, but anyway, we'll see. Power supply will be under here. We've got the ventilation, of course, is fine. The fan sucks in here and it sucks from this side and blows out that side, and Bob's your uncle. That's about it. So there, whether or not there's any additional heat sinking inside on the there probably won't be ASICs, there'll be FPGAs in there. So let's take it off. Not the best quality metalwork I've seen. A little bit how you doing there, if you can see that. But anyway, it's built down to a price. So there you go. As you can see, we did get threaded metal inserts in there. Absolutely brilliant. Other scopes have just got self-tappers. Anyway, I'm starting to take the screws out here. Yes, they do have the thread locker on them, but all this metalwork seems like it's like not lined up properly and sort of squeezed in a little bit. It's almost like they were, half a millimetre out on the drawings or something. Anyway, not a big deal, just something I noticed. And there you go, we're in like Flynn, and that's all rather neat and tidy. Power supply is smaller than I thought. I expected like a big long one in there, but they've just got like half size in there. It's in its own shielded can. Of course, that's pretty much mandatory. Shake-proof washer up there, is it? Anyway, no, it's not a shake-proof washer, but it'd have the thread locker on there. So the mains earth has done really well, got no problems with that at all. We'll try and get the cover off that power supply and have a squiz at it. Just one cable coming over, one cable for the fan, and there's the board. Neat. Okay, this looks pretty much par for the course for any modern digital scope. We've got our analog front end here. Hopefully we'll get the can off that. We've got our external trigger circuitry over here, a little relay in there. As I think when I did the review of this, I didn't hear any relays click in the front section, so I'm not sure if it has any. Anyway, we'll have a squiz under there. This is obviously our main acquisition FPGA under there. I doubt it's an ASIC. I'm pretty sure it's an FPGA. It looks like they've thermal adhesived that heatsink onto that chip, so unfortunately we're not going to get that off. Sorry folks, I really want to be careful with this one. It's the only one in the country. Anyway, looks like we've got our sample memory we'll take a look at in a minute. And anyway, hopefully get the can off. What else have we got? And totally unpopulated BGA and memory here. Well, no surprises for guessing what that's for. Here's our logic analyzer connector down here, so they haven't populated any of that. So you can forget about like hardware enabling, just whacking in the connector, hardware enabling. And of course, they're going to get the price down by, the logic analyzer modules don't have the chip, the memory, or any of the passives or anything else fitted. So yeah, that's actually fairly simplistic. We've just got some input protection there, and unless there's stuff on the other side of the board, I don't know whether or not we'll get to that today, but anyway, fairly simplistic logic analyzer stuff by the looks of it. We've got a little RF connector down here. Now what that's doing, I don't know. Some sort of external reference clock, external test connector or something. These cost a little pretty penny each, so I don't know why they're populating it there if it's not being used at all. I thought they'd be trying to shave every last cent off this puppy. Anyway, all of our DC to DC converter stuff around there, it's not worth looking at. We've got ourselves, that's probably our Ethernet up here, so Ethernet and USB around there, nothing doing here. We've got our JTAG header up here, fan control, I don't know if it's under firmware control or not, or whether or not it's just running full tilt. Anyway, analog devices DSP, and we've got ourselves a Lattice FPGA. We'll have a take a closer look, dead giveaway what that puppy's doing and the associated memory here. That's our display connector, so clearly that's our display driver, display processor. So this has got a reasonably quick display update rate. In fact, in burst mode, it's up to like 400,000 waveforms per second, but you have to watch my review video to see the caveats with that. Anyway, so yeah, we've got ourselves the front end. Maybe, is that our ADC down there, our dual channel ADC? Anyway, we'll take a closer look at that. Going in our acquisition engine, there's our capture memory. There's probably duplicate chips on the other side, so could double the amount of memory there. We'll have to have a squiz. That looks like our main oscillator in there, and of course our analog devices DSP up here. That'll be doing all the main GUI type stuff, the operating system and the USB, the user interface, all that sort of stuff, and our display ASIC / FPGA here. So it'll be funneling the data most likely directly from the acquisition ASIC over here into the display ASIC here. It'll be totally bypassing this processor. This processor wouldn't be doing the waveform updating, but it'd be doing stuff like math and things like that. I don't think they're doing that inside the display ASIC down here. And there we go. We've got an analog devices Blackfin DSP. I think it's almost exactly like the one used in the Rigol scope. So it seems to be the go-to device for these types of scopes. I wonder why. Is it the programming environment? Is it the cost? Is it the, what is it? Well, what we've got here for our display processor FPGA, it's kind of, is it an FPGA, is it a CPLD? It's kind of like a combination of both. It's the Lattice LCMX0640, and it's part of the Mark XO family, and you won't see around the outside of this, you won't see a a flash memory for the configurable bit stream, because this is a non-volatile device, boots instantly. It doesn't need an external memory to hold the bit stream, and it's pretty pedestrian. It's like $10 a DigiKey. It's like 640 lookup tables, not much. 6K of distributed RAM in there, so nothing special. Pretty pedestrian FPGA. And it looks like we've got expansion flash memory. That X on there would be one of the production operators saying, yep, I've firmware programmed that puppy. And the DSP, of course, has some memory coupled onto that. These would be logic translators by the looks of it. I haven't even looked at the part number for those, but that'd be my guess. Dead giveaway that, there's 3 of them. It looks like they're, in the I/O path. And well, sure enough, at second glance, if you actually take out some of the numbers in here, 245 at the end of it, you might recognize, 74HC 245 and AVC there. Well, that's a family, so this is a 74 AVC 245. So yep, definitely used for logic level translation. So it seems like those logic level translators would be converting between a level for the DSP up here and a level for the FPGA, but these FPGAs are, have all the requisite interfaces, 3.3, 2.5, 1.8, 1.2, blah, blah, blah. So yeah, not sure what the deal is there. Anyway, logic level translation. So there's our oscillator there. I don't know. Doesn't even seem to have a brand on that puppy. Got resistors everywhere. And lots of unpopulated cap. Don't know that part number off the top of my head. Interestingly, look, battery missing for the real-time clock. Yeah. Where is the battery? Does this thing not have a real-time clock in it? I can't remember. I haven't actually checked the firmware to see if it has a date time stamp for any function. Maybe it doesn't. So there you go. What is that connector doing there? I mean, this is obviously a little driver for it for outputting whatever signal it happens to be, but they've gone to a bit of expense there, and well, I don't know why. So what we've got here is some SRAM coupled onto the main acquisition FPGA here, and decoding that part number. I've never heard of NetSol before. I don't actually recall them. Anyway, we're looking at a 9 megabit synchronous pipeline burst SRAM, so it's designed for, really fast, low latency update, all that sort of stuff. Exactly what this thing needs for that, that 4,000 waveforms updates per second burst mode, that this sampling mode, that this sort of that this scope's actually capable of. But of course, it's in a 512K bit by 18-bit arrangement. So I don't know, are they doing a checksum with the extra 2 bits in there? Anyway, that only works out to 128K sample memory for that. So this is not being used as the main sample memory, because it's supposed to have 14 meg. So presumably that's what that puppy on this side here is for. So that puppy there, and if you know that number off the top of your head, well, my hat's off to you. It's bloody cryptic. You've got to go into the micron. That's what the M stands for there. That's the micron trademark, their logo, and you got to go. They've got like a part number decoder you whack into their website, because they got these weird ass part code numbers in there. Anyway, this is an MT41J64M16JT-15. Of course it is. It's bleedingly obvious. It's a 64 megabit DDR3, 1333, 666 megahertz. DDR DRAM. So there you go. Pretty quick. So 64 megabits, 8 meg samples effectively. So this thing's got 14 meg samples total. So there must be a second one on the other side. And it looks like they've got 2 DC to DC converters here locally right next to the SRAM. Well, they're actually powering not only the memory, but powering the main acquisition ASIC as well. And here is the ADC wedged in between the main acquisition ASIC there and the CAN, which we'll take a look at under shortly. And I recognise that puppy. That's the HAD 1511. That's from a company called Hittite. We may have seen a Hittite ADC in another teardown somewhere. I'm sure we have. Anyway, this is a 1 gig sample per second, as the banner spec on this scope says, 1 gig sample per second ADC. Now, it's actually 4 ADCs in here, and it interleaves those to actually get the 1 gig sample per second total rate. So, of course, they've only got the 1 in here. They haven't got 1 per channel. So, of course, as I showed in the review, when you actually turn on the second channel, the sample rate drops from 1 gig sample per second to 500 meg samples per second. So, yeah, that's the downside of this, because, you know, these things aren't cheap. It would have been nice to put 2 in there, and then, you know, you got to double the stuff in your acquisition ASIC and everything else. But they decided, nope, we'll just use the 1 and halve the bit rate, which is pretty annoying for a 200 megahertz bandwidth scope. As I mentioned, 1 gig sample per second is fine for one channel. It meets that minimum times 4 multiplier requirement, but it doesn't when you halve that to 500 meg samples per second. It effectively limits the usable bandwidth down to about 125 megahertz or so. And for those playing along at home with the trigger input, just a bit of a pan down there, not going to go into that. It's, yeah, knock yourself out. Sorry for the jittery pan here. It's not very professional, is it? Lots of unpopulated stuff down there. Look at that. Tons of it. What's missing? Where's Wally? And on the side of the can here, we're going to have some trigger pick-off from the analog channels too, presumably. Look, a 7905 voltage regulator, surface mount tucked in here. Is that for the low noise analog front end? Because this thing is supposed to have a true 500 microvolts per division front end. But look at what they have out here in addition to this negative 5 volt regulator. Look, they've got some LP 3878s. I suspected they might, so I had a closer look at these. These are low noise adjustable low dropout voltage regulators. So they're low noise, of course, designed to get the low noise performance for powering the circuitry on the analog front end. Nice. Although granted, they've only got 2 of those well, maybe there's 1 per channel, I'm not sure, or whether or not 2 power both channels, and they're common. In that case, you might get a little teensy bit of crosstalk between channels. Oh, boo-hoo. If we take a look at the analog front end here, I won't go into a huge amount of detail. I'll post some high-res photos for those who want to look at it, but it's all passive around here. So maybe there's some active circuitry on the bottom. I'm not going to take this board out today. Yeah, there could be something on the bottom, I'm not sure, but it's all passive networks right up until here. We've got a couple of trannies in there by the looks of it, or are they diodes? Can't see the silk. So diodes, are they D1, D2? Yeah, they could be diodes instead of transistors. Yep. Oh no, Q. There we go. Got a transistor over here. That's Q. So anyway, if we go up here, here's where all the action's happening. This is a, if we can get that number, trust me, it's an Analog Devices AD8370, and that's a variable gain amplifier / ADC driver. So that's the puppy that's doing most of a good lot of the gain, plus the main line driver straight to the ADC, which isn't far, by the way. It's just got to pop across there. No big deal. And that thing down in there, I'm not sure what it is. It's got H1K hash 513. So I'm not exactly sure what that puppy's doing. But apart from that, nothing special. I mean, we've got a 74HC, 595 up here. That's just doing some driving stuff. We've got a Cosmo solid state relay there, so that's not uncommon. You find those all the time in these front ends. Not sure what that puppy there is. Can't quite make out the part number on that, I'm afraid. So yeah, there's not too much else exciting there. Yeah, so unfortunately there's nothing in there that's telling me that they're doing anything special for the 500 microvolt front end. Got a couple of NEC relays, of course. I was wrong on the relays. They got 3 of those puppies under there. Spared no expense. NECs, they're not one-hung lows. NECs make pretty good relays, yeah, but apart from that, unless there's stuff on the bottom side, but yeah, as I said, I probably don't want to take the whole board out today, unfortunately. And right next to our ADC here, no surprises for finding the ADF4360-7. This is a VCO, it's the PLL to generate the ADC clock. And you can see some inductors in there. Look at those puppies. There we go. Few of them there, so hopefully they've got there all the loop filter components around here and whatnot to enable that. So hopefully they've done that right, unlike Rigol, who goofed up their loop filter values and yeah, they got jitter. So there was a jitter problem on the Rygols, which they fixed by tweaking the, luckily for them, by tweaking the coefficients inside this thing. So they were able to fix it. Anyway, so unless somebody can actually reverse engineer that and have a look at, but we don't know the exact values. I'm not going to go in there and measure them. Let's assume it works. Well, hello, sailor. Here's the power supply. At first glance, this looks pretty well done. Nice and clean and tidy. Got our huge bypass cap, but there's the first thing. Lelon brand. Fail. Anyway, we've got our bridge rectifier in there. We've got our common mode choke in there. We've got, our suppression caps. Is that a MOV in there as well? But look at all the Silastics sticking down. Those output caps, they really don't want those flapping around in the breeze. We've got our opto coupler, nice isolation slots there. I'm sure they've all got the requisite rated components, another isolation slot down in there. They're doing the business. That's not too shabby at all. And there's the primary side switch in, nice looking heatsink there, nice looking copper strap over the main switching transformer there. And that's pretty decent. Check out the little heat sinks. They've a bit of attention to detail there. They probably don't want it to run too hot, but they probably didn't want to, put any major, probably didn't require any major heatsink work in there. But yeah, that is a neat little power supply. What are those output caps? Are they Rubicons? I think they're Rubicons. They've done a decent brand there. Why haven't they done a decent brand for the main input cap? Oh, what a bummer. But apart from that, that is a neato looking power supply. Siglent branded. Whether or not they actually did it themselves or farmed it out, as is most common in the industry to do, we don't know. So there you have it. That's not a total look inside the new Siglent 1000X series, but that's probably as far as I'm going to go today. I don't want to have to take out the rip off the tape for this and get the flat flexes out and take it all out. And sorry, I want this thing. It's the only one in the country. Yeah, I'm a scaredy cat. Anyway, no, I just couldn't be bothered. I'm actually running out of time. So, yeah, we're not going to see a huge amount. For people who want to analyse the front ends and stuff like that, well, I'm sure somebody else will do a more thorough teardown with more professional pictures once they get one. No big deal. We know there's an extra memory chip on the back of there. There's probably an extra one of those on the back of there. Nothing too much doing. Else apart from that on the back side, I'm sure. So, yeah, don't get all upset that you didn't see the bottom side. There you go. It was just too easy to access this top side. And anyway, that is quite a nice little design. I don't mind it at all. Apart from the sample rate, of course, which, is an issue with this thing. It's a 200 megahertz bandwidth, 1 gig sample per second, not shared. Apart from that, they haven't got much horsepower. I'm surprised the amount of, the lack of horsepower they got to drive the screen. There's not much there at all. Not much to it. And once again, sorry, but we don't know what's under there. That thermal adhesive is really tough to get off. I really stand a good chance of damaging that puppy if I take it off. Shame they don't have it down with a clip or anything like that. But yeah, it's a fairly simplistic design. You can see how it's been built down to a cost, although they haven't really skimped a huge amount. Once again, they got stuff like this connector and that circuitry populated for no apparent reason. And yeah, it's not like Madman Muntz has got in there and ripped out components until it stopped working and then put the last one back in and said ship it. So yeah, they've done a reasonable amount of engineering. And by the way, if you don't know who Madman Muntz is, I recommend you Google it. That's in there for the old timers. All right, just for kicks, I've powered this thing up. We've got a little flashing heartbeat light there. We've got one over here, and we'll get the flare on this puppy and take a look at the thermal profile of this. Here we go. No surprises for finding a hot little regulator over there. So that's part of the switch mode, 36 odd degrees. You know, not much doing on the main video processor chip there. The main DSP, not much doing up there. 32 degrees. No surprises for finding all the actions happening down here. That's the real hot spot there, which I'm probing now is at 50 degrees. No fan, by the way. I haven't got the fan turned on, so there's no airflow. So this is not a fair, real world test. It'd actually be probably, at least 10 degrees lower than this or something like that. And then around, you can see all the board as well around the main FPGA there, the acquisition FPGA. The reason why the FPGA looks cool is because that's the emissivity of the silver heatsink there. So yeah, it's not calibrated for that emissivity, so it appears cooler than it actually is. If that was a black heatsink, we'd have black anodized heatsink. It would show up just fine. But anyway, ADC is the real hot puppy in there, and the board surrounding that is, a good 10 degrees cooler. So not quite sure what the FPGA up here is. Is that... Oh, I can keep my finger on there, so it's under 50. It's in the high 40s, it's in the mid to high 40s maybe. So anyway, that's not too shabby at all. Just did that for a bit of fun.
It was a salesman, basically.
Oh yeah. Hang on, I've got that upside down. What a knob! What a wally! Fair income. And check it out, the sticker's back. No one will be none the wiser. Look at that, beauty. Let's power this puppy up. See she still works. By the way, that power supply might look decent inside, but bloody hell, takes, as I showed in the thing, it takes like 8 watts or something on standby. Absolutely ridiculous. And it's got like one of those stupid heartbeat LED things, which is always running. Oh, God, 8 watts just to do a heartbeat LED. Gotta be kidding me. Anyway, there we go. It's booting up. We have my old homemade clock here from the 1980s. Winner, winner, chicken dinner. So as always, teardown, high-res teardown photos available on EEVblog.com, and forum links, and leave YouTube comments and all that sort of jazz. And as always, if you like it, please give it a big thumbs up, rate, comment, subscribe, support me on Patreon and all that sort of stuff. Follow me on Twitter, blah, 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 buy the merch, Catch you next time.